In this video we're continuing Markov chains, and instead of looking at tree diagrams we're going to use more equations to solve it. Now it's very useful, this method, when you need to work out how many people or a quantity amount at each stage rather than just a probability, and it's also useful for when we're going to transition matrices, in that if you can understand this algebraic equations, then the matrices make a lot more sense. So we'll begin with an example and then I'll show how it's used. So here's an example. So a school canteen sells only pizza and curry. So as you can see, only two options which fit in, as we only look at two state Markov chains. Then if a student buys pizza one day, then they have a 40% chance of buying pizza the next day. If a student purchases a curry, they have a 70% chance of buying pizza the next day. So from this we can see that it looks like a Markov question. Now I do have to be careful here. So you highlight what's important. They have a 40% of chance of buying pizza if they bought it one day. So if they buy pizza, then there's a 40% chance that they'll buy pizza the next day. Then, if a student purchases curry, they have a 70% chance of buying pizza. So here's a slight trick in regards to, it's not 70% chance of them buying curry again, it's now buying pizza. So this one was pizza, this one is now curry, pizza. So that's fine, we can still derive the four equations, you just have to be mindful of that. And we'll make note of that later on. So the actual question, if 50 students buy a curry and 50 students buy a pizza, then how many students buy the curry and how many students buy pizza on the days Tuesday and Wednesday? So this was talking about Monday, so they've given us some initial conditions here. So the initial was if 50 students buy a curry and 50 students buy a pizza, 50 students buy a pizza, then how many students buy curry at each of these days? So if you're doing this by a tree diagram, you'd have to work out the probability at each of the days and then times it by the number of students, and it will get a bit messy. So what we can do here is we can start off, we can work out, we have to get the four probabilities that we want. So they said that, let's quickly look at the question, there's a 40% chance of them buying a pizza if on the previous day there was pizza. So from that we can know that there's a 60% chance of them buying a curry if the previous was pizza. And that was just calculated because that has to sum up to 100% or 0.4, 0.6. Now the other one they gave was a 70% chance of pizza if previous was curry, and then a 30% chance, we can calculate that, as I said, just 1 minus 0.7. This gives us 30% chance of curry if previous was curry. So now what we're going to look at is, we'll begin by looking at pizza. So we need an equation really that sort of shows us what number of students eat pizza. So the number of students eating pizza, so you can sort of think of the number of pizza, is equal to 0.4, like the pizza PO. And what I'm going to say with PO is equal to like the number that ate the previous pizza. So that's here. So why is it 0.4? Well, let's say there's 100 people who ate pizza one day. Then using expected value, or working out, there's 40% chance that they'll eat pizza again. There was 100 who ate there. Therefore, you could expect that on average 40 students would eat pizza the next day. So it's 100 times 0.4, so 40 students would eat pizza the next day. So as you can see, this is where this comes in. It's 0.4 times PO, which is a previous pizza. But then we have to account for the students who ate curry, who will then eat pizza the next day. So as you can see, that's 70%. So that's plus 0.7 plus curry O. And then when CO is equal to the number who ate curry previously. So the number of people who eat pizza is equal to 0.4, that's where that comes in, times PO, which is a number of previous, it's probably easier to put like number of people who previously ate pizza, plus 0.7 for the number of people who ate curry previously. Then, let's still some room. So make sure you can understand that. And then from this, we can show that the curry equation is equal to the number of people who eat curry is equal to 0.6 PO, and that's because 60% of people who ate pizza then ate curry on the next day, plus 0.3 CO, which is because 30% of people eat curry the next day if they had curry the previous day. And as you can see here, these sum to 1 and these sum to 1. Because we're assuming that if someone buys something from the canteen, they then buy it the next day as well. So that means everybody who eats curry previously then has to buy something else, and that's either curry or pizza. Everyone who buys pizza then has to eat something else. So we get 0.6 and 0.4. So now we already know Monday, so now we need to work out what Tuesday is. So Monday we said it was 50-50, if you remember the question. It was 50 students with curry, and then 50 students with pizza. So we can calculate Tuesday by saying that curry on Tuesday is equal to 0.6 times 50, because 50 students ate pizza previously, that's like PO and CO, plus 0.3 times 50. And then we can calculate pizza by going that pizza T is equal to 0.4 PO plus, so you can sub in 50 for PO, times 50 plus 0.7 times 50. And so that gives us, for the so the curry on Tuesday is equal to 45. So you just work that out. So the curry on Tuesday is equal to 45. And then the pizza on Tuesday is equal to 55. So you could obviously work these out. But another way to think about it is that if there were 50 students plus 50 students, so in a total there were 100 students on one day, and then we're saying that they all purchase on the next day, then obviously these two numbers, CT plus PT, must also equal 100. So another way you could have worked out 55 was by going that 100 minus 45 would have to equal 55. And that's a good way to check that CT plus PT must be equal to like C on Monday plus P on Monday. Yeah, so we've calculated Tuesday, so now let's look at Wednesday. Yeah, so Wednesday we have C Wednesday is equal to 0.6, so we're looking at curry at the moment, times PT plus 0.3 times CT. So before here though, the P is sort of initial, C initial. But why don't we use those initial values? Well, we don't use initial values because Markov Chains is about the previous. It's about working out what the probability, the number is, given that the previous outcome. So the Wednesday, the initial was Monday. So we don't care at all about Monday anymore. All we care about is Tuesday, because the Tuesday affects Wednesday. So with the COPO, what this represents is the previous one. That's what it, yeah. And initially, you can put the initial values in, but as it goes on, it's the previous amount. So PT is equal to 55. So we get 0.6 times 55 plus 0.3 times 45. And then we can work out pizza on Wednesday is equal to 0.4 times pizza on Tuesday plus 0.7 curry on Tuesday. So that gives us 0.4 times 55 plus 0.7 times the curry on Tuesday, which is 45. So working that out, we get 46.5. That's the amount of people who eat curry on Wednesday. And then calculating the amount of people who eat pizza on Wednesday gives us 53.5. And as you can see here, they add up to 100 again. So it started off as 50-50, then it went to 45-55, and then they started to converge back up again and a bit closer to 50. And that's because the people who eat pizza are mainly from the people who eat curry. So if the number of people who eat curry decreases, then the number of people who eat pizza the next day will also decrease. However, they will reach a steady state. So in the long run, there will be sort of an average number of people who eat curry and an average number of people who eat pizza, so that given that these probabilities and these conditional probabilities, they will always have the same amount eating. Obviously, it won't be the same people, but the same total number of people who eat curry one day and the same total number of people who eat pizza will be the same. Thanks for watching.